a process that involves gain of electrons. So, going beyond these two definitions, there's a lot to unpack. The first thing is that both processes are complementary. The short form is what's called redox, and they are complementary. Complementary in the sense that one cannot happen without the other happening. So as oxidation is happening, reduction is also occurring. So they happen simultaneously and move electrons in opposite directions. So while oxidation involves the substance losing electron, reduction involves another substance accepting those same electrons lost by the other substance. But let's dive deep. What are the areas we really need to know so that we can answer questions easily? There are sorry, who is okay. Someone just joined. Hello? Adini Florence. Who's that? Okay, let's continue. So, the next part of importance is how do we identify oxidation reaction and then reduction reaction? Because those are one of the questions that will be displayed shortly. It'll be good to identify them in a sample redox reaction. Now, the first way to look at it easily so that you can remember oxidation is addition of oxygen. So you may see addition of oxygen. So if the substance involves oxygen being added to it, we say it's oxidation. Then obviously reduction will be the opposite. That will be removal of oxygen. So let me narrow it down for you. If a substance is giving out oxygen, then that substance is undergoing oxidation. If a substance is removing oxygen, then that substance removing the oxygen is undergoing reduction. We're going to see samples shortly. Then the second one would be removal of hydrogen. Or this one would be addition of hydrogen. So when you look at the processes in combination with oxygen and hydrogen, you can see there's a sort of opposing nature to it. Where oxidation involves addition of oxygen, reduction is the process that involves removal. Where oxidation involves removal of hydrogen, reduction is addition of hydrogen. Let me try and get you quick equations that can help. Okay, I have one here. To showcase these two things that we're talking about. For the first one, we're looking at, I have something on halogens, how halogens respond. So you have hydrogen sulfide plus bromine, and then at the end of the day you have hydrogen bromide. sulfur. Now let's look at this closely because we'll be seeing questions like this shortly. We'll try and answer it together. So you can see here the hydrogens with the sulfur here, but here it has lost its hydrogen. So it's safe to say that the sulfur added the hydrogen to what? Hydrogen bromide, to bromine. The sulfur added the hydrogen to bromine. So since the sulfur lost the hydrogen, sulfur experienced what? So we have removal of hydrogen. Let me take it again slowly. You can see that the sulfur on this side does not have its hydrogen, but here it has hydrogen. On this side, bromine is alone, but on this side, bromine acquired the hydrogen that sulfur gave away. So when we look at sulfur from this side to this side, we'll say sulfur experienced what? Removal of what? Hydrogen, which is what? Oxidation. While bromine got hydrogen added to it, so we say addition of hydrogen, that will be what? Redox. Did we get that? Any question? Did you get that? Okay, good. So there will be questions that look like this, where they will tell you to identify oxidation, reduction from complete chemical equations and not ionic equations. So okay, Michelle has joined us, so let's continue. Yeah, let's look at addition of electronegative elements. That's the third one. So oxidation involves addition of electronegative elements, and electronegative elements are elements that have the ability to attract electrons to themselves. So for example, oxygen, chlorine, sulfur. Is there a question? If you have a question, just raise your hand. While for reduction is removal. So for reduction is removal of electronegative elements. So the last one is actually the one commonly used, and will usher in another angle that I want us to look at, and that's loss of electrons and then gain of electrons. So let's take a review again. Okay. I think Esther just joined us. Okay. For those of us just joining, we just started oxidation and reduction, and this is everything we've covered so far. Gotten the definition, we've gotten the relationships, and then we're trying to look at the difference with respect to how they ask questions on it, and some questions will be displayed shortly for us to answer together. So we said oxidation, addition of oxygen, while it is removal of oxygen here. For oxidation is the removal of hydrogen, while it is addition of hydrogen here. Then we showcased an actual equation that looks like something they ask in WAEC or UTME, where they will tell you to identify the substance undergoing oxidation or identify the substance undergoing reduction. So that was what we covered here. So we said because sulfur lost its hydrogen by the time it got to the product side, and that hydrogen was accepted by bromine. So removal of hydrogen, oxidation, addition of hydrogen by the bromine, reduction. So we'll be taking more questions like this shortly. Then of course, addition of electronegative elements is also another one to consider. Addition of electronegative is another one to consider. And then the last one, loss of electrons and gain of electrons. That one is kind of the easiest way to determine which process is undergoing oxidation and reduction. So let's try an example on loss and gain of electrons. So the most common one would be, let's say you had loss. And then you have iodine. Okay, now imagine a question like this, and then it asks you to identify the reacting species undergoing oxidation or the reacting species undergoing reduction. The fastest way to go about it would be to use the number line method. There's no shame in drawing it over and over again till you get used to it. If it is going this way, it's what? Oxidation. Because increasing this way shows that the substance from the reactant side to the product side is losing electrons. And if your valency or your oxidation number is increasing or is going this way, in this direction, then it's undergoing what? Reduction. So going back to the question for iodine is going from -2 to 0. So we say that any substance in its molecular state or atomic state should be considered with a charge of what? 0. So for -2 to 0, so when you check -2 to 0 going this way, with the way the arrows are going, you can see that it's going what? Oxidation. So the iodine is experiencing oxidation. Then for iron is going from 2 times +2, so that's what? +4, and here it is. Okay, I think there's an error in the equation itself. It is 3 here, sorry. So it's so iron here is what? +6. +6 is saying 2 times 3, while here it is what? +4. So you trace it from, let's say we continue up to +6. You have +5, you have +4, 3. So going this way, so looking at the arrow from +6 to +4, then you can see it's undergoing what? Reduction. So your iron is undergoing reduction. So that is how to use the number line effectively. So from +4, +6, undergoing what? reduction. So I think someone has a question. Okay, yeah. What's the question? Toby, unmute your mic. Yeah. Okay, unmute your mic and ask a question. Toby first. Here is -1 times 2. Get this -2 that we have here. So iodine is going from -2 to, so we said when you have your substances in their molecular state or their atomic state, that they will have a charge of what? 0. So -2 to 0. So when we followed the number line, we saw that going this way, oxidation, while going this way, reduction. So we're able to follow that iodine experienced oxidation based on going from -2 towards to 0. Then on the other one, doing 2 times 3 plus, of course that was how we got the +6. 2 times +3, we got +6, and we said if +4 is somewhere here and +6 is somewhere here, we're going this way, following the arrow of what? Reduction. So this is how loss of electrons can help to identify substance undergoing oxidation and substance undergoing reduction. So this is the easy part. The next level is where, instead of asking for the process, they are asking for the substance. So the process is one thing. The substance that carries out the process is completely different. So the first one, when they say oxidizing agent, now this is a substance that accepts electrons in a redox reaction. Okay, sorry about that. That accepts electrons in a redox reaction. That's what I'm oxidizing agent. Emphasis on accepts electrons. Substance that accepts electrons in a redox reaction. Okay, let me help you line it. So then the second one is the reducing agent. Reducing agents, this is the substance that gives electrons in a redox reaction. I think someone has a question for me in WhatsApp. Okay, Toby again. What is the question? So for reducing agents, this is the substance that donates or gives electrons in a redox reaction. And oxidizing agents accept, a reducing agents donate. Okay. Oh, are you for it? It's two substances. We require very deep examples so that we can identify them easily. Substance that accepts electrons, substance that donates electrons. So for the one that accepts electrons, we're calling it an oxidizing agent. While the one that let's call it OA. While the one that donates electrons, we're calling it a reducing agent. Let's call it what? RA. Going back to that same equation that we used, or we should use something different. Okay, let's get something different that we can use. Okay, I have one here. So let's say zinc plus minus, and then we have chlorine doesn't change. Okay, the chlorine won't be the perfect one. Let's say hydrogen will be the perfect one, and then on the other side then we balance it. We're still going to learn how to do all this shortly. Okay, so let's take this equation as an example. Hydrogen is molecular state, the rest aqueous solid. So if we were told to identify the oxidizing agent or the reducing agent, this could be a typical UTME question or a WIC objective question. If we are told to identify the oxidizing agent and reducing agent, what do we do? The first step is to know which substance is undergoing oxidation and which one is undergoing reduction. So in its atomic state, sodium has a charge of what? 0. Sodium has a charge of what? 0. So here it is what? Plus 2. So from 0 to plus 2. If you go back to that number line, from 0 to plus 2 is obviously following what? Oxidation. So our zinc is experiencing what? Oxidation. So from what we learned earlier, that oxidation and reduction are complementary reaction. As one is happening, the second one too is what is also happening. So it means the hydrogen to this one that is going from plus 2 towards the charge of 0 is obviously what? Reduction. Now that's the first step. Once you identify the process, it is now easy for you to identify the agent, that is the substance that each reacting species represents. Now the one undergoing oxidation, when you look at it, which of the agents looks like an oxidation process is being carried out when you define it? When we look at reducing agent, they say this is the substance that donates, and you know that oxidation involves what? Loss of electron. Oxidation involves loss of electron. That is where a substance donates electron, which means a reducing agent is the one that undergoes oxidation, while an oxidizing agent is the one that undergoes reduction. So that's the short tip. The process to the substance are opposite to one another. The process is opposite to the substance. I think that will help you remember. Process is opposite substance. So that's one short way to always remember under pressure. Reducing agent is the one that undergoes oxidation. So oxidation RA, while reduction OA. So I think if you remember this, no matter how hard the questions are, you'll be able to wiggle your way and choose the right one. So obviously our zinc is our reducing agent, while our hydrogen plus whatever substance it was is our oxidizing agent. So seeing this now, let's see whether we can attempt one or two questions on this topic. But before we go, let's take another example of where we have been asked to identify oxidizing and reducing agents. Okay. So process is opposite to substance, that is oxidation is the one undergoing oxidation is the reducing agent, and the one undergoing reduction is the oxidizing agent. So let's get another question. So okay, I have one here, and I think this will help us in follow-up 30 minutes that we're going to use to answer questions. I'm sure we're familiar with manganese. It's been in our faces for a while now. Element. So when we look at it, this is +7, and here it is what +2. If we look up the progression of the numbers from +7 to +2, who can tell us? Okay, let's do it together. There's still a session for who can tell us. So quickly we draw it again. Now you're going to +7, then not sure you are coming this way. So obviously if it goes this way, you know that it is oxidation. If it goes this way, it is what? Redox. So from +7 to +2 would be what? That's following this way. Oh, obviously going this way. You know, the arrow appears. So your manganese oxide is undergoing reduction. While for your 2+ to 3+, following this way, your iron is undergoing what? Oxidation. So from what we've learned earlier, we said oxidation Ra and reduction OA. So reduction OA. So this is our oxidizing agent, while oxidation Ra, this is our reducing agent. I feel like with this, we should have gotten the soul of how this concept works. And this for, okay, sorry. So we should have gotten how the concept works by now. So with this, there's just one last thing to cover, and that is oxidation number calculations. Although I believe you still remember this, just to show one example, because it's very common in UTME, and it will be very bad if you see it and you gag on the chart. okay, is a cation. If what is undergoing oxidation is a cation, for example, this situation here, and it will look like as if the oxidation number is what is increasing. Are you following now? If what is undergoing oxidation is a cation, but if what is undergoing oxidation is an anion, like for example, if I want to rewrite this equation for you using iodine, sorry, I would write it like this. I would say manganese 7 plus. Now I would show that, okay, if I'm to rephrase it, I think here I want the manganese to donate electrons, so here to be what, 2 plus, then the iodine will accept the electrons. Not even sure to balance this, so let's just remove it. Okay, you can still put it, though we know it's not balanced. So in a situation like this now, that's just it. I think when it's undergoing oxidation, as you can see, from 2 plus 7 plus is obviously undergoing oxidation, and is our reducing agent, while from here to here, 0 to 2 minus is undergoing reduction. So I think that's just it generally. Maybe when we, you know that when you are dealing with a compound, IUPAC nomenclature, for those of us that are used to it by now, we have to name this compound. So you call the first one potassium, you call the third one, say because of the 3 is a trioxo, then the one in the middle, chlorate, and then there's always an oxidation number to end it. Now you know normally you do that by calculating. You say potassium plus 1 based on its normal valency, chlorine is what you are looking for, so you say plus X depending on the number of chlorine atoms. Then oxygen is minus 2 in how many places? 3 places. So we do this, okay. So now because it is a compound, the charge of any compound equals to 0. I repeat, the charge of any compound, just like the way the charge of a molecular gas or element in the atomic state is 0, the charge of a compound is also equals to what? 0. So everything will be equal to what? 0. If we solve for x quickly, to be minus 6, sorry, plus 6, to be plus 6 minus 1, then plus 5. So to be triazochlorate 5. Now this is a compound, but what if we are dealing with the ion? We are dealing with the ionic form attached to this compound. Are we still going to get 5 for chlorine? So the ionic form should be triazochlorate triazochlorate with a negative, yes, triazochlorate with a negative, yeah. And we are asked to confirm if chlorine will still have a charge of 5. So this is basically the anion after we have removed the potassium from it. So that's just the difference. So this one is the compound. This one is the radical attached to it. So we go, we're looking for chlorine plus oxygen minus 2 in how many places? everything equals to what? The total charge. So we call this the net charge. That's what we call it. The total charge. So this minus covers both chlorine and oxygen combined. That's why their charges or the oxidation number is equal to it. So it will be -1. Then x, that's -1 plus 6, and that also still give us what? 5. So the difference in the solution is that for compound we equated to what? We equated to 0, but for the radical we equated to the what? We equated to the what? The net charge. So if a radical has a net charge, let's say for example something like this, and you're looking for carbon, it will be x -2 in 3 places, every equals to the net charge. The net charge here is what? -2. So that's the effect. Whatever the net charge is what you equate a radical to. So x equals 4. So this will be trioxocarbonate 4. So I guess with this we can finally end the first session of this topic. How many minutes do we have left? I think we have just like 9 minutes left. Before we go, some common examples, because in the questions I'm going to showcase for UTME, we talked about examples, common examples of oxidizing agents. Let's come to see them, and reducing agents. For reducing agents, I'll just say general examples are metals. General examples are metals. Oxidizing agents. General examples of sulfur oxide, TMNO4, CR27. You'll be seeing some of these questions shortly. Acids generally, make good oxidizing agents, so not just one. Acids make good oxidizing agents. So, and so on and so forth. I guess as we answer questions, we'll uncover more oxidizing and reducing agents. So in the next 5 minutes, I'll send you another link where we'll now answer questions, UTME questions.